Okay, the first lesson in this unit is just an intro to rational numbers. So we're going to kind of use some definitions here. So the number system classifies, and I'm writing with my finger, so hopefully you can read it. The number system classifies numbers based on their type and characteristics. So you've probably heard of whole numbers. So that's the set of all positive counting numbers, starting with 0. So examples would be 0, 1, 2, 3, 4, going on and on. I always say this is what you would teach like a little kid how to count. And it just goes on forever as long as they're positive, whole. Natural numbers are the set of positive, so I'm going to put the plus sign, integers. So for example, it's everything from up there except not the 0. So it's 1, 2, 3, and so on. And they have to be whole. So it's everything but the 0. Integers is the set of, they have to be whole numbers, so they can't be fractions unless it would be like a fraction of 12 over 6, which really equals 2. So it's the set of whole numbers and their opposites. So basically it's everything from up above there, and then you add in their opposites. So like -5, 3. Positive numbers are also considered integers. -200. Okay, it would not be like -2/3. So even though it's negative, it doesn't mean it's an integer. They have to be whole. And then rational numbers describes all the numbers that can be written as fractions, terminating decimals, which means they stop, and repeating decimals. So for example, 5.2, because that stops. Let's see. Another one would be like a -2.3 with a repeat. So it has to stop, which means terminate, or repeat. Or they can be fractions like 9/3, because when you reduce that, it equals 3. Okay, so we're going to determine if the fraction below is terminating or repeating. And you are not supposed to use a calculator on this unit. So somewhere off to the side, you would do your division, because remember, this fraction line just means to divide. So you would do 5 divided by 6. The top number always goes in the calculator first if you were going to use it, or in the box. And then remember, you can add a decimal point and some zeros and put your decimal point up right away. And then you go ahead and divide. So 6 goes into 50 8 times, and you have 48. Subtracting it 2, bring down your 0. And then 6 times 3 is 18. And then you should notice that it's going to just keep repeating with the 20. So you know your answer is 0.83, and the 3 is the only thing repeating. And you may put a 0 here. So that would be considered repeating. So go ahead and do that with 2 11ths and 17 20ths. And I'm going to have you pause the video and then come back and see if you got what I did. Okay, so you can check out what you got, 0.18 repeating and 0.85. Hopefully you were able to get those. If not, you can always ask questions. Okay, so you're going to label the different parts of the number system. This is just a diagram to help you. So we have whole, and I actually went ahead and labeled them for you. We have whole on the inside. So if we think of some numbers that would be whole, we know 0 is considered whole. And we can just name some different numbers there. 5, 2,000. Anything that is whole, and it has to also be positive. Then the integers add in those opposites. So we could have negative 2,000. We could have a positive 3 still, because that's the integers are positive and negative whole numbers. And then rationals would be anything that it could be all of those, and also fractions that turn into repeating or terminating decimals. So 3/4, if you divide it, that's 0.75. So that would be rational. 2.4. Negative 1/8. Any of those would either stop or repeat. So is it possible for a number to be both a whole number and an integer? You stop and think about that. Okay, so I have an example. The number 7 would be a whole number, but it's also an integer. So that would be true in that sense. But for negative 3, that is not a whole number, but it's an integer. So is it possible for a number to be both? Yes, but it doesn't have to be. Okay, if we flip our paper over, we are just going to be practicing a little review of fractions and decimals before we start getting into with the negative numbers. So on here, you can fill this in if you want, but you know you need a common denominator. So I'm just going to put a D for denominator. Then you know you make new fractions. You know that you add the numerators, the top number, and then you keep the denominator the same. For decimals, you rewrite the problem up and down, but again, you don't have to. That's just a good strategy. You line up the decimals and you fill in with zeros if you need to. That just helps you. And so you go ahead and do those, and let's see if you get what I got. Okay, go ahead and look at my answers. This one, hopefully you were able to do unless you just added wrong. And you can pause it if you want to re-look at it or rewind it. This one, I tried to show you that I turned 1 1/2 into 3/2 and then made that out of eighths. So I times by 4. And then I got 19/8, and then I reduced that to here. So if you got 19/8, you're on the right track. Okay, go ahead and pause it and do the next two. Okay, so if we look at this one first, you should have gotten this answer. Remember to do column by column starting at the right. So if you need help on that, you can ask someone. I didn't have room for the work. On this one, I changed this into an improper and wrote it here. And then I changed them both out of 12. And before this, you might have gotten 25/12, and then it reduces to this. Okay, so I'm going to go ahead and have you try these and see if you get what I got. So pause the video again while you do them. Okay, so go ahead and check out the work with the fractions. I tried to show more. Again, if like on number 5 here, if you get this answer, that's good, but we want you to reduce it to 1 5/12. I tried to show you the work. So go ahead and pause it if you need more time to look at it. Make sure you do homework number 1 now that goes with this and check your answers.